I'm going to be talking about diversity, disconnection, discord, and other pleasant properties of collective intelligence. I'm James Evans. I'm at the University of Chicago, Santa Fe Institute, and Google, and I run a center called Knowledge Lab. And I think in the discussion, which I've thoroughly enjoyed, I feel bad that I wasn't able to make it earlier in the week. There's been a lot of celebration of cooperation, a lot of holding hands around the collective problem solving, a lot of kumbaya, and I just wanted to kind of lean into what I think of as the kind of the limits of homophily, similarity, and kind of concert in the context of cooperation and collective intelligence. So I run my center, Knowledge Lab, really focuses on a kind of a complex system view of knowledge in which we think about complex knowers as agents that are sharing various sensations, representations, understandings, expectations, strategies in kind of complex networks and exchanges, to ask the question of how do collectives as systems think and how can they think better relative to a variety of different values. And I've spent most of my career thinking about this in the context of science and technology development more broadly, but I increasingly have been thinking about and measuring this in the context of the broader information environment and other contexts of cultural and intellectual production. And my orientation is really how to observe and understand innovation according to this generative standard that in some ways, Richard Feynman promoted, when he was, really at the dawn of nanotechnology. If I didn't build it, then I don't understand it, which has kind of been echoed in the context of computational social science. If you didn't grow it, you didn't explain it. And so I spend a fair bit of time trying to think about how to simulate and automate innovative processes, either in kind of toy agents or in large-scale simulative and predictive systems in the context of the social sciences, the natural sciences, kind of feeding intelligence into robotic, physical, wet labs in pharmacology and material science, and investment areas in the context of both kind of nations who are trying to invest strategically in science and individual investors. So I would say, one foundational thought here is just the idea, the possibility of the wisdom of crowds. So this, in some ways, was formalized in the context of Francis Galton. So this is Charles Darwin's cousin, paper called Vox Populi, The Voice of the People, published in Nature in 1907, in which he goes to this West of England fat stock and poultry exhibition. There's a dressed ox, which is to say a killed and slaughtered ox, not this healthy young ox here, and 800 people paid for the ability to put in a vote, a bet, and the average of those bets was less than 0.1% off. It was 1 imperial pound. It was better than any particular prediction. The median was about 0.8% off. Now, I think what's critical about this situation is it's not like us, like our collective here was at this fat stock and poultry exhibition. Like we would have totally failed this task. The fact is there were diverse data and approaches. Everybody who was there owned one 10 or in some cases from auctioneers and large-scale buyers, thousands of oxen. And they knew what theirs weighed precisely because they were at the fat stock and poultry exhibition like they were trading. And then they compared theirs relative to this assessed standard. So the diversity underlying this task, which wasn't really realized, I would say, as a property of collective intelligence till almost 100 years later, ends up being a critical driver of this property. And so I'm going to be thinking about the wisdom of diverse and disconnected crowds in the context of scientific, technological, business, and societal conversations. And the diversities that I'm going to be thinking about are kind of cognitive diversities, perceptual diversities, experiential diversities. Some of these are driven by identity-based diversities, which put people in different situations whereby they're exposed to different experiences, percepts, and cognitive situations. And encoding diversity, the way in which people actually represent their knowledge in such a way that that the combination ends up creating conflict and innovation. And the flip side of this is, of course, the stupidity of similar and disconnected crowds for a variety of different kinds of tasks. And so, of course, we thought about the problems of monoculture and monocropping and other kinds of domains, cultural objects on the interwebs, we see, even though there's a long tail in the sales division of of stores like Amazon, the mass of the distribution is much closer to the center than it's ever been before. Language extinction occurs increasingly and more rapidly with social contact. Biological extinction obviously increases and has increased with ecological contact. And some of the things that we've explored is, what does this look like in the context of knowledge, science, and technology? So this is a PNAS paper a couple of years ago in which we showed that as fields grow, their canons crystallize. So basically, as they grow, there's this exponential decline in the likelihood that new ideas enter the canon and part of the discourse in the broader conversation. So there's like a collective capacity, a carrying capacity of ideas within a conversation. And we can show the same thing, for example, if you look at two physics departments, the likelihood or increase in collaboration between those departments ends up driving a collapse in the relative attention or foci of attention between those two departments, which we've played around with representation in kind of hyperbolic space to kind of capture those ridges across the space. So one way to think about this in a more detailed scenarios, we looked at this in the context of the physical sciences and the biological sciences by building this simple generative hypergraph model. When I say simple, I really mean that it's like a representation of the scientific papers are extremely simple. Like these are just bags of keywords and journals from which you might draw ideas. And so the ideas were just we're maximizing the likelihood of this draw of papers in this particular year by wrinkling this manifold in which different ideas, concepts, keywords, journals live, right? So we wrinkle that, we maximize the likelihood of this hypergraph, right, as a function through this manifold space, and then we allow it to move with Brownian motion to the next period, and we draw down this Poisson draw of the hypergraph in the next period, and that's our prediction. And it turns out that it's got an AUC of about 0.95, so it predicts most of the papers that show up in the next period, and that shouldn't be surprising just because we are inertial, I mean, if you look at, your sequence of papers, you're adding the occasional keyword, you're dropping the occasional keyword, think about the sequence of talks and slides that you've produced in the past. But then it raises the question and opportunity of, what happens when papers show up which are the most surprising, right, or the most unpredictable relative to this most predictable scheme, right? So this is kind of like, here's the flow of papers that the system would expect. It expects most of them correctly, but papers show up that are not, are violated by this. And we find that systematically that those things that are most surprising to this kind of most predictive system end up being surprising to the scientists as well, and driving and predicting, for example, almost 60% of the likelihood of being in the top 10% of citations across the physical sciences, the biological sciences, invention, et cetera. And so the question becomes, okay, so what are these unusual papers doing? Well, they're drawing ideas that have never been drawn together before, and they're drawing them across communities, right, across sources that have never been combined before. So they're basically, broaching conversations that haven't existed in the past. The question is, where do these things come from? And systematically, we find they come through kind of career team and what I call expedition novelty. So to a lesser extent, people with unusual combinations of prior experiences end up producing low levels of novelty at about almost exactly the same rate as combinations of people in a team, Jason and the Argonauts, like pulling together random strengths. Surprising teams produce these. In higher levels, at both the biological and the physical sciences, as well as in invention, we find expeditions predicting this high in novelty, which are people who move from one part of the scientific or technological space, and they come over to another place and solve the problem that was surprising. They make unsurprising the problem that was surprising in this other space. And the reason why expeditions and not teams is because teams require, and careers require a kind of a social contract that it is profitable to combine these things in the past. And so expeditions are basically groups that are making ventures that may not be successful. They're about 40% less productive, but they're about 70% more disruptive, according to a couple of measures that I'll bring up in just a moment. So this kind of suggests, if we were to ask the question from this, how does innovative systems think, or intelligent systems relative to an unfolding and changing frontier of problems? And if we were to take, from the philosophical quiver of thinking cartoons, do they deduce, from logically, do they logically extend from facts or axioms? They do. That's 95% of our prediction. That's the vast majority of what it is that they do. Do they imaginatively generalize from observations or engage in induction? They do occasionally engage in surprise, but it really, I would say, it's better characterized by Charles Sanders Peirce's notion of abduction, which is surprise-driven science, where basically induction and deduction kind of collide, right? So you set up the experiment or the observation, you set up the theoretical framework for your field, it's violated by a set of observations or experience which are made unsurprising by people outside the field, which is one of the reasons I think abduction really never took off as a mode of individual thinking, because it's much more likely to take place across people, right? Across people or societies or the world, in which you have a broader carrying capacity so that people can thrive with the development of logics that become useful for problems that haven't yet been anticipated across the system. So, oh yeah, shoot.
I was just wondering about the kind of underlying vision for science and some of this work. Like is novelty the goal, or is novelty the outcome that we want to maximize when we're thinking about scientific teams as a kind of
so at the National Institutes of Health, if you look at their mandate, it's about developing new medicines and treatments to solve currently unsolved problems. So if you look at the vast majority of their investments, they are feeding mouths from the past, and they're in fact there are a series of studies that we did that looked at the process of review, and that process of review systematically showed that the most critical factor in granting funds to papers is if you looked at the hot streak of those papers kind of in time, and what you found systematically is the moment that those papers and that stream of research became irrelevant, basically, to the science frontier, is the moment at which they were funded by the NIH, on average. So on average, it has a strong depressive effect. It's not just a neutral effect, it's not another objective, it is an anti-innovation objective for basically kind of like putting up, the former contrastive. So I think it is one of the things that we want to do. I think it's an important thing that we want to do. I don't think it's the only thing, but according to simulations and other things, it is way undervalued and under-supported in these institutions relative to its optimality, even if you class it as a minority objective. Sure.
I just wanted to, along the same lines, I mean, of course, when you make a web page for something, you always want to say that this is about new and advancing and so on, right? Because this is what everybody expects. But then, at the same time, if you're interested in impact of, say, medicine or particular medication and so forth, the impact may not be at the moment where it's created. It's when it's engineered in the right way, when people have figured out how to use it the right way and so forth. And that is already where, in terms of the number of citations, that original paper is probably going to be tanking. So I'm wondering if you're really picking up the right signal if you think in this way.
Yes and no. So it turns out that you're absolutely right that a lot of the ingenuity and the human impact comes at the downstream development. But we're talking about other scientific developments which are in the class, in the pool of the basic development. So it's not like those less impactful advances are the things that are doing the engineering work. That's not the work. That's not the engineering the work. That's another pool of resources, pool of funding, and we just got a large grant from NSF to look specifically at the level of product innovation. And it looks like we see a very similar thing undercapitalization for novel validation of scientific findings. So so it looks like the level of development is a parallel process of undercapitalization. I mean, underlying this question is, what does it mean to innovate? What does it mean to build institutions that systematically innovate? It's an oxymoron, right? We're basically building institutions to solidify processes that we systematically violate, which means that to build institutions that support science is surfing this boundary between order and chaos, which is not going to look like institutions. I mean, are not going to look like the same kinds of institutions that we've built.
What you just said, the review process involves bureaucracy, effectively. The same people, more or less, they try to modify this. So the only way to deal with this is to introduce competition.
Yes, okay, so hold that thought. I've got some work on competition that shows, I think, precisely that, but I'll love your feedback.
Do surprising papers fail to replicate more often? Because I'd have the inclination that might be the case.
Yeah. They have, but it's tricky to completely measure because it turns out there's a lot of fallacious papers that are totally boring that nobody goes after, right? So if you actually look at if you look at the breadth of attention, so people are like, oh, these surprising, findings, and certainly this has been the claim in psychology, in certain areas of psychology, especially sociology, that we don't, we want to go after these, but it turns out that if you just look at the relative rate of attention by which you would want to replicate these things, it turns out that it's very likely, and there's no evidence to disabuse us of the fact that there are many more boring findings which are fallacious. So it's not, I think getting that rate is a challenge because it requires massive replication of things that everybody feels like they know. So there's a capital problem. I'm going to take 2 more questions and then I'm going to move on. Yeah.
So there is novel findings and there is paradigm shifts in science. When we are within a paradigm, we can't even see outside of it. Like right now, the paradigm we are very deeply in is optimization. We can't even imagine how we could think about intelligence.
Except you can, apparently. Yeah.
Versus wave theory for light. There's different things along the history of science where the issue wasn't just a matter of novelty, it was completely different ways of looking at what is going on. And it's also in ideas, it's not just in that. So do you make a distinction between just novel approaches versus something that is, let's say, a paradigm shift?
We've looked at this at about 3 scales. I think it's really hard to look at massive scales because they happen like once in 100 years, right? So I think we'll need to rerun the world a few times, maybe thousands of times to be able to get distinction on very large tectonic shifts. But we see the phenomena scaling across levels from like individual components and technologies used to large complex combinations of components and real kind of counter-real theoretical approaches. So, okay, last one.
When there's like an innovation, right? How do you know that it's going to be revolutionary? How do you know? I need to grow this idea, or I need to fund your government's funding agency. How do you know?
Right. Well, I think you don't, but I think that our point here is this is all ex ante measurement. Right, so there's no ex post like, oh, we were surprised. Oh, we're going to disproportionately cite this thing and not the things on which it builds. This is all about to what degree does this re-wrinkle or fold the manifold of ideas at the moment it becomes a preprint, right? So that says it's novel. And what we're showing here is that there is a meaningful correlation between surprise that's certified, right, that turns into a paper, not necessarily a published paper, and actually, the attention, it's an attention-seeking system that becomes an innovation in this context. So you could imagine it's just like, well, yeah, and it's true, if we were to consider all the things that anybody considered at all grade levels, every, confusion, then of course, the vast majority of novelties will fail. So these are novelties that basically inspired like a paper that passes, right? Yeah, so there's a selective threshold here And that's a critical cost question when you think about the rate of novelty that you need to kind of carry small and large scale, societal scale innovation. Absolutely. It's going to be costly. It's not going to be inexpensive. It's not mostly going to work. And it's not just because those things are false. It's also because, why did, Betamax die and VHS succeed? Because it also, plugs into the engineering, human, theoretical, and cultural infrastructure of current science. And I think these are things that we're trying to explore and piece out. So a couple of, one question about, where does this disconnection come from in general? And it looks like it comes by accident. So this is a survey of about 30,000 scientists. We randomly selected them stratified across a set of fields, across levels of impact. We randomly selected 2 papers from among their citations, and we asked them how they found them, how influential or impact it was for their paper. And then we basically assayed those papers relative to the universe of social collaborations and ideas underlying the space, with embedding models, with social networks, over the metadata, basically, that describes who's co-authoring with who, and systematically find that the biggest signal is for things to have intellectual influence that you ascribe without knowing that it's signaling who's written what in the paper, are things that are written by people at the same institution but in different departments, right? So how do you come in contact with these people? Maybe through IPAM, maybe on the soccer field, maybe at the Whole Foods or like wherever you shop. I mean, this is about people living in proximity with one another without the expectation that one's surprising problems will be solved and made unsurprising by someone else's kind of alien solutions in this context. We find another set of boundaries in the context of the status order of citation. So here we see the relative likelihood that people cite in one direction relative to another. So, for example, psychiatry is much more likely to cite neuroscience than neuroscience is to cite psychiatry. Electrical engineering, is much more likely to cite physics than the converse. Genetics and heredity is more likely to cell biology than the converse. So you see these cascades of status and attention. But systematically, you find when papers violate those expectations, which is to say when they cite down against status, first, there's clear discrimination, which is to say it's much more likely for them to cite the paper and not the papers that it cites in the violating discipline. It's also much more likely that that paper that launders the ideas from the lower status field ends up having both the high mean and variance of impact within the core field. And it's more likely that the people who are in the institution from the higher status place are co-located with the people in the lower status place. And it's more likely that they're married to one another. Like, these are truly random events that end up, so it's not like, the scientific system is optimally searching through the space of possible information stores. It's that sometimes it gets wired accidentally to these places, which disproportionately yield impact because the field is myopically not looking in those places. And so it suggests an improved or increased level of sampling. And so we've kind of build views of the relative value of every field from the perspective of every other field at any particular point in time, right? As a function of the relative impact of those ideas and the relative attention to those ideas across the scientific space. And now we're engaged in a bunch of conference experiments. So IPAM, let's talk. I'm working with MC, which is our Chicago variant, to think about how to basically build on kind of underrepresented but high surprising, impactful, and underreported impactful findings across the scientific space. We find a similar thing when we look at cultural products, not only in science, but in technology, in the production of screenplays and films, in the production of new companies by entrepreneurs. We find when we basically encode people's positions as a function of their production of prior objects, right? So these are not probabilities, these are people inside some evolving transformer-based embedding space. And if you see two concepts, let's say two words in the space moving together over time, then the angle of these people with respect to these objects strongly predicts the likelihood that they will see and combine them, right? And this is independent if we take out the possibility that their combination is driving the construction of the space. So this is independent of that construction of the space. So the same is true for them approaching and seeing things across the space in general. So for example, this person is going to be like sandwiched by these two concepts coming at them. This person, equidistant to them, one eclipses the other, is much, much, much less likely to combine those things in the future. And then what we find systematically is that products end up, cultural products, so this is in the context of movies and new ventures, end up systematically being disproportionately successful as a function of the diversity, the angles of the people with respect to the object that they create inside the space, and inversely proportional to their background diversity, which is to say they're much more successful if the people are converging towards the idea and bring this plume of alien experiences to bear in the construction of these objects. We find the same if we don't look at perspectives, but we just look at the objects themselves. So we talked about scientific innovation as a function of combinatorics over the space. In venture-funded startups, there's something different than the scientific space, which those of us who spend a little time in both and the vast majority in the academic space knows is speed. Like in startups, if you're venture-funded, you have to show a minimum viable product in like 1 to 3 years. And so what we find in these contexts is the same combination of components across the space, but they're using components, which is to say already established technologies and ideas that are well forged inside, in this particular case, in the business space. How does the people talk about businesses growing up? And they combine those radically, widely across the space. This is strongly predictive of the likelihood of achieving IPOs and high-priced acquisitions. And it's inverse, which is to say, working on maybe scientific low-level innovations that combine, for example, a first technological possibility with its first application, are much more likely to close and fail. So again, it's like the whole system is ratcheted up a different level. In this case, it's a system that really relies on the existence of a science to create those modules, right? It doesn't exist on its own. We find this in the context of social media production as well. The diversity ends up driving public informational benefits. So in the context of Wikipedia, if we look at individuals' contributions to different kinds of web pages, and we code their political bias as a function of the bits that they contribute to these recursively, which is to say, if I contribute to, let's say, Ronald Reagan, and I'm conservative, then it's much less likely that that's a signal that I'm a conservative because he's also very popular and contributed to by a lot of liberals. So if we basically recursively pull that thing across, it produces a signal about 33% predictive of both self-described ideology and voting likelihood across these spaces. And then we find systematically that the more polarization, in this case, just the diversity in that political space, ends up systematically being associated with the quality of the pages by those independent, people who are unaware of the process by which those pages are produced. The signal is strongest because it's political diversity for political pages. And it's less strong for scientific pages, but still present. And when we look at scientific diversity, we find the same thing in the context of scientific pages. Now, one of the critical things of this polarization is that this polarization is variance, which means it has to be balanced contribution. And we find, in fact, when there's imbalanced contribution, then that's much more likely that there's going to be, that the imbalanced, the single warrior on one side of a debate will be framed independent of their actual contributions as a troll and excluded from the space, and lead to high, what I euphemistically call temperature in the talk pages underlying the space. We find that this diversity is important, but it can't be necessarily too conflictual. So I'm not sure, is Jinsol here? No, I don't see him here. Anyway, he probably knows what I'm talking about. So, what? Whoa, okay. Yes?
No, Jinsol is there.
Oh, that was Jinsol.
Yeah.
Oh, wow, you're kind of blockier than I'd remembered. But okay, I'm glad you're here. I'm sure there are others here. I don't even want to. If I labeled some random person, then it's, hi Jeannie and the kids. So here we look at misinformation and fact checking on Twitter, now X, and we find that diversity ends up being important for identifying misinformation, but that when you see vigilante curation, where individuals just go out on the web and they just like slap people with fact checks, and they slap them, with kind of toxic language and in really kind of abrupt, infantile speech, then it turns out that rather than kind of bursting epistemic bubbles, it creates those bubbles. So people, they were becoming more diverse, both in their political consumption and production and their content diversity. And then, like, the slap itself is the thing that creates the bubble as they kind of like, crawl back into their information hole. Very different when we look at collective curation style approaches like Birdwatch, which is now Community Opinions, where those tags, which are only revealed as a function of diverse political persuasions who don't vote the same on other classes of topics, deem the thing, which is to say the fact check, as universally helpful, is it revealed? And that revelation basically doesn't lead to the same collapse inside the information space. So, one question is, can we design diversity to increase collective imagination and intelligence? Like, can we turn this into an experiment? So one, in this context, we're not just trying to create digital doubles of individuals or collectives in this space, but we're trying to create cultural or cognitive aliens that think differently about how this space evolves. And so, one playful attempt was a paper that Jun Sol participated in on how to build reservoirs of difference in the context of these online spaces. And so here, we just created a cocktail party, basically, of different LLMs conversing with one another, selecting one another, conversing with one another. Over time, they created these, first they as they were cross-trained effectively, they came to prefer people who spoke like them. And in fact, at the limit, these clusters ended up not necessarily being entirely in English. They were like kind of Chinglish, Chinese, English, Cyrillic characters that were unique to that subgroup. And it turns out not only were they more likely, when we harvested diversity from them, to perform well on creative tasks, but they're also much more robust to social poisoning. So for example, if you engage in public goods tasks and you put a poisonous or really selfish agent in the space, if they were plain vanilla untrained agents, then their bad behavior would spread like wildfire. In this context, it appeared that basically agents in the system could identify in-group and out-group. And they didn't basically pass on bad behavior from the out-group to those inside the in-group. So this is one way of thinking about, how do we start designing, if we're thinking about a world of billions of digital agents, how do we, and we can't necessarily train them, how do we build systems that will allow them to train each other to generate the diversity that's critical? Another project, we were looking more specifically in the context of discovery in the material sciences and pharmacology. So we built off of this paper that basically just built a simple embedding approach to predict the likelihood that any particular chemical would have a valuable property, right? So thermoelectricity, ferroelectricity, photovoltaic capacity. In our case, we look more broadly at about 500 different diseases that we were exploring. So this was not our paper, but we thought, well, what if we actually took into account the diversity of perspectives within this space? And so we, instead of encoding just the words in sequence across the space, instead we basically threaded together random processes that simulated conversations and experiences. So we basically built a random walk that walked through this hypergraph and jumped, for example, from a property like photovoltaic capacity to a person, to a paper with that property, to a person who wrote that paper, to another paper by that person, to another author on that paper, to a material on that project. And so we encoded, first acontextually and then later through transformers, this whole space, which is basically trying to capture those inferences that are most likely to be made cognitively by scientists in the space. And we find that encoding basically improves the prediction by 100 to 400% over just encoding the text itself, because Basically, our predictors, which are these blue ones with the black dots, which are those that are successful, are just sitting atop these. These are density maps of scientists in the space. They're sitting atop these density ridges. So these are the things that are going to occur to scientists that live in the space. No one's going to ask the questions that live inside these dells that lie between the space. And we know this is true because we have, almost 0.5 precision on who precisely is going to make that discovery that is made. Any particular discovery that's made over the course of the next 20 years, if it's the next year, we can predict 1 in 2 of the people who will have discovered it as a function of their complex position in this high-dimensional space of ideas. So representing people within these spaces is both kind of discriminative or descriptive, but also predictive. So now if we invert this, we get this digital double of the system, things that people are likely to see. And obviously, to be clear, by the time we're predicting 18 years into the future, our predictions about who is going to be there are worse. Why? Because most of the people have not been academically born yet. But if we invert this, we end up doing even better. What does that mean? That means we're basically building predictions that are avoiding humans in the space. But they also have a signal of the scientific likelihood of those connections, right? Through, in this case, word embedding, and then we're predicting against the likelihood that these materials actually have the desired properties in question. And we find, on average, and invariance, that basically as you move away from the human space, you end up getting a big boost in the relative likelihood that these end up effectively having these properties in question because the system was blind to them. And so we're building, in this case, not cognitive aliens. I mean, we can understand what these properties are, but cultural aliens, aliens that couldn't have been produced in our distribution of scientific education from the past. And when they are rarely discovered by scientists in the space, they're discovered years or decades into the future. Now I think given my time, this part will be a montage. I just wanted to state the inverse, which is kind of across innovators, teams, and fields, that dense connections distort collective certainty and slow novel discovery or advance. This is the collective stupidity side of the argument, right? So in the context of, for example, scientific papers, there are a series of papers that we've written, one in Nature and PNAS, and then another one that is about to come out about how it is that large, tall, which is to say hierarchical, and smooth, which is to say like evenly distributed people across these idea space teams end up producing production. So they produce papers. They're a critical part of this ecology, but they systematically dampen disruption, whereas small, kind of flat and sparse teams amplify the likelihood that conflict will occur in the context of those teams and amplify this disruptive potential. So one measure that we're using in the context of disruption is just a structural measure that captures the degree to which, when we produce an artifact of some kind, it eclipses the work on which it builds. This is an ex post measure, and it predicts basically it captures the likelihood that stories are told about this thing that frame it as the first in a series of new developments rather than another brick in the wall. And it turns out that it has these nice properties. First, it captures the relative difference between reviews and original articles, between developmental work and Nobel Prize winning work. It also is just simply correlated with, for example, these are the most likely verbs, nouns, and articles or prepositions associated with kind of like the limits of the least disruption and the most disruption. So endorse, confirm, and demonstrate versus change, innovate, introduce, and advance. So it's capturing ex ante as well as ex post features of the process of search through this space. And we find systematically that as teams grow in size, that they exponentially decline in the likelihood that they're going to disrupt this frontier. We find that as team structure, so we measure structure just as a function of, in about 100,000 papers, we have individually described contributions to papers. When you cluster those contributions by people, it's obvious what the roles are, right? So lead, write, conceive, design, coordinate, interpret, versus collect, analyze, carry, purify, versus, comment, contribute, discuss. So I would kind of think of it loosely as kind of leading, direct support, and indirect support that you might summarize as kind of brains, muscle, and fat. inside the space, we find, yeah, I participated somehow and maybe commented on the manuscript. Anyway, I won't go there. But we find systematically is this kind of L ratio, the lead ratio, so the number of people that contributed to thinking and designing and conceiving of the paper is systematically associated with greater novelty of combination across elements in the space and basically in much more the inverse of this developmental, this disruption, which kind of is precisely the opposite of this. It's also, these teams are also much more equitable, and while they're less productive for people at the top of the hierarchy, they're much more productive for people at the bottom of the hierarchy, actually, who are involved in a greater distribution or portfolio of projects. They're also more likely to predict the future. One of the reasons is why large teams and hierarchical teams are much more likely to cite and build on recent prior hits, right? And so they're basically, managing their continued dominance through basic, well, you think about a production studio. Are you going to invest in Slumdog Millionaire or Transformers 9? Transformers 9, it's going to get Transformers 8 receipts minus epsilon. This is a way of hedging your bets across the space, and it builds, it's like momentum investing. And these large teams are much more quickly able to kind of harness those advances, and so almost all of their advances or citations come immediately. And small teams, those citations come, if ever, in the longer term where they're systematically more impactful as well as disruptive. We find a similar thing when we look at the topology of the scientific space. So, for example, and this was a complete flub on my side, I kind of thought, well, how do teams manage this problem of diversely spanning the space and bringing together unusual ideas? I thought, well, maybe if they tessellate themselves across the scientific space, then they can facilitate conversation between any pair and kind of enable the management of this complexity versus this persistent homology that identifies the whole as the same size as the diameter, right? Between two groups that are very different from one another. And I was completely wrong. It was the opposite. It's basically when you have these huge holes, this systematically activates a search and conflict. Again, they're about 45% less productive. They're much, much more, about 200% more disruptive inside these spaces. And so if you want to optimally kind of smoothly search the scientific surface like hill climbing, assuming that it's just one big molehill, then this is what you would do. You basically leverage scientific agreements that exist currently. If you want to kind of search out the space, kind of a fear that you might be in a local maxima, then you would want to activate conflict, basically in the context of these. What's that? So this is whatever dimension kind of embedding space, either in large language models and in kind of other embedding models. So this is kind of effectively dimensionless quality. This can be interpreted as, I would say the distance can be interpreted as kind of, alienness or difference, and then the lack of productivity. And it turns out the rate of grants pursued to those grants received suggests that these are both more failure prone, more conflictual, and more confused. No, across the entire space. Yep, yeah. So it turns out this is true not only for innovation, but also for replication. And so, for example, lots of people have talked about this kind of replication crisis more broadly. I'm literally going to blaze through this. What we find systematically is when we line up findings to high throughput replications of those findings through massive high throughput experiments that basically test, in this context, genetic combinations through about 200 perturbations and experiments apiece, we find that systematically social independence, methodological independence, and prior knowledge independence are much more likely to produce findings that replicate across this space. So as you increase the social dependence, and as you decrease centralization, which is to say the number of projects on which core authors are involved, then you dramatically increase the likelihood that findings will replicate in the future and form a kind of a stable basis for scientific replication. This is a paper that's coming out next week in Nature Human Behavior, which shows that you can predict the likelihood that things will collapse in the scientific space as a function of bubbles, right, where they have like high attention, in the short term, but they don't diffuse across the scientific and social space, right? So other people try to use them, they can't use them. They try to combine them, they can't combine them. And then it increases the likelihood that you can predict both fraud and just a collapse in relative attention across these scientific contexts, which suggests particular competition policies. Like if you just literally, increase the number of claim communities which are disconnected from one another, that are completely authorially connected, or if you increase the spread of scientists across the broad space, rather than kind of clustering in the same space, you dramatically increase the likelihood that all of the findings, kind of across the whole distribution of findings, collective certainty is achieved in this space. And you can also use this to just calculate a kind of a Bayesian uncertainty update to the system as a function of these effective collusions inside the space. The third and final kind of like broad limitation, and I see I'm coming close on my end. How close am I?
You have extra time because we started 4 minutes late, so maybe.
That's so generous. Thank you. Okay. So basically, we've spent a fair bit of time in the last couple of years thinking about how it is that different languages encode things in different ways. And in particular, for example, the likelihood that ideas end up being semantically close across discourse in the space increases the likelihood that you're going to predict, for example, if someone is taking a TOEFL exam, we have all the TOEFL exams here, the likelihood that they will come up with a certain metaphor to describe or solve a particular problem in this context. And the likelihood that two people across language domains will be confused at one another's speech because they're drawing upon disjoint metaphor spaces that are more or less available to them inside this scientific, or inside this broad process. Furthermore, it looks like we have really differences in the kind of information density of languages. So this is the distribution of language information density that we just measure as a function of the Huffman coding of parallel corpora, right? So from the Bible and Old and New Testament to EU documents to the KDE online manuals to whatever. And we find systematically this relationship between semantic density, so this is the relative proximity of any word to any other word in the space. And what this means is basically that there's this polysemous, this general polysemousness across languages that highly varies. So at this high information density, you're using many words to refer to many different kinds of things and kind of a chaotic network across the space. In this far end, one word means one thing, and it's not replicated or reused across the space. And it turns out that systematically, this ends up being both predictive of the speed of communication, so more dense languages, you communicate the same content faster, but you basically traverse the space in natural conversations or discursive events much more slowly. So it's almost, it's like the system is critical, which is to say you talk about the same things in more different ways over and over again, as potentially part of a process to refine the sub-specific meaning that's relevant in a particular context. And what's interesting is if you look at all of the historically late and large languages, which is to say just the populations that they're connected to, they end up moving towards this middle, which is to say it looks like there's some potential historical optimization process by which either through association with other languages in adoption or through just the functionality and selection of the language themselves, that there's this optimal balance or some kind of evolved balance in this system over time. We looked at some of this likelihood for words to be ambiguous or non-ambiguous, not only across languages but in scientific fields. And we find systematically when we just basically evaluate the ambiguity as a function of the entropy of a word across a variety of contexts, which would basically make it less likely to be specific. An unsurprising array, from humanities, down to the physical sciences and chemistry, using natural language in the most precise way. But we find systematically with greater ambiguity within any particular field, you have a lower fragmentation of the work that builds on you. So rather than, rather than, basically, more ambiguity creates community and engagement around classes of problems which are themselves fundamentally ambiguous. So the ambiguity actually drives a kind of a collective process and potential conflict, which creates actually much more integrated citation spaces that result. We've been trying to look at this in the context of neural networks as a whole, and find that we also see kind of, so about 60% of transformers in deep neural networks have been discovered by other deep neural networks, right? So things like the non-monotonic activation function, or, which was developed by reinforcement learning, or things like the, in this case, the residual networks, right? So ResNets are this kind of likelihood of basically building a layer that kind of crosses multiple layers. And so we basically asked the question, well, what are some of these things doing inside the space? And we find that the ResNets end up, and this part of it was just kind of reimagining these networks from neural networks to social networks, that basically that this ResNet architecture kind of quasi-maximizes the frustration of the cycles and triangles involved in the underlying gradient updates, right? So basically, if I've got a two-stage connection, those are positive. One-stage connection, those are negative. As a result of adding that connection, it increases the positivity and negativity. So it makes the whole network basically lie in this critical state where it decreases the likelihood that it will have to unlearn findings as a function of new data, right? So it's able to tip in this really kind of chaotic, fragile way across the space. Again, conflict here is the thing that kind of allows it to sit in the space that makes it optimally learnable. And we find when we optimize for that conflict, rather than doing it kind of in this kind of quasi way, we do much better at both making the network sparser and also more learnable. So, to kind of conclude, I'll say, this suggests, that we might want to conserve human diversity, cultivate algorithmic diversity, and design collective diversity of kind of humans and digital agents to kind of sustainably innovate and kind of facilitate collective cognition. And this suggests that innovation in science, technology, enterprise, and culture are high-dimensional, rugged landscapes requiring social, cultural, intellectual, institutional, and methodological disconnection. I think a critical thing in the space is the high dimensionality of the space. So this was a study I was commissioned to do recently by Congress, where they wanted to look at competition between countries in science and technology. And of course, we see competition. China's running up from behind, and the U.S. is flagging, and like everyone's like rooting, on either side. And if you expand the dimensionality of the space in this context, where we're just looking at the relative focus on emerging fields, which is partly a result of just a very different age pyramid in the context of Chinese science, we find that it's much more likely for Chinese science to be working in these emerging fields and emerging areas over time. And so to think of this as a competition is just a function of some very low-dimensional collapse inside the space, and leads us to policies that are expensive to China and would be very expensive to us, for example. So, just kind of a final idea, insofar as we're building these large language model and other AI stand-ins for human agents and complements of human agents. There's a lot of reasons to do this. I won't talk about it in depth here, but we know what these transformer architectures look like. I won't talk about them again. But I would argue that one of the challenges with modern transformers is that they are not diverse, right? So increasingly, as we've kind of moved up the revisioning chain of GPTs, they've become much less entropic over time. And I would argue that they really need to learn from not just social cultural science, but social and cultural diversity. So, for example, they have extreme positivity and political bias. You saw that for those of you who saw Junsol's poster outside. And so this suggests the need to kind of evolve optimal diversity that basically straightens them across the space. Another is this uniformity bias. And so, of course, they're trained with this enormous centroid of kind of collective shared semantic attachment. So one way, a hack, is to think of individuals and collectives as quantum entanglements of multiple perspectives. It's much more predictive of the moves that they're going to make in the future. And to basically build in parallel models, stream of life models, that feed them with context and keep them basically diverse across the space. Those can be natural diversities or other diversities, and I can talk offline about a variety of approaches that we're taking to do this. They have an atemporality bias, so basically they need web scale data, and so we train them on web scale data, which means they're not chronologically trained. They don't have a predictive sense of the future, which means they don't have a surprise. Like, we can't test their surprise relative to things that are emerging. So they can find things that are expected, but they can't recognize the surprise signal that is like the core of this abductive approach to scientific development. So we just got a fairly $20 million grant to kind of build chronological transformers that increase this likelihood of kind of surprisingness. So they're going to make boring predictions, but they're going to be surprised at the right things that would effectively fold the space productively. They have a monolingual bias. We can talk about this. And they have a senseless bias. I mean, they, for example, are much more likely to be biased in, for example, images and video than they are in text. And it turns out that if you do kind of chain of reasoning across these modalities, you can metricate, you can measure this relative bias. And the idea is we can both train that back in, and we can also increase the likelihood of multimodality in the space. And I'll just throw out, mathematical opportunities that I'm excited about, exploring at IPAM is thinking about individual and collective innovation, certainty, discovery, obsolescence, with different modes of combinatorics, function spaces, complex geometries and topologies that allow us to shrink wrap, I would say, these otherwise really flabby high-dimensional models, which is to say most of those dimensions are not doing much work, so that we can shrink wrap them to be much more predictive positively and negatively, so that we can use them as theoretical devices. Anyway, with that, I'll close. Thank you.